I will lead to our last presentation for today. It's about a neural network multi-agent architecture applied to field bus intelligent control. The presentation will be made by Mr. Vinicius Monte Machado from Universidade Federal do Piauí. He is a professor at this university and also a PhD student.
Thank you for the introduction. This work has another authors of two institutions in Brazil. So we are following these topics. We're talking about first for the problem, then we will introduce the function block intelligent algorithm concept to better understand our work. Then we're talking about our multi-agent architecture itself, and we will close in with an example and talking some conclusions of this work. Well, this is a typical foundation field bus environment. We have two levels, the supervisory level, okay, and the field bus level, communication through the gateway, generally a ETFA. So, we have some activities in this environment. Some made by humans, some made by automatically by the system. Okay? Activities like network management, devices, field devices allocation, control strategies, and alarms interpretation, and some monitoring tasks, and network administration. Our objective is to introduce some kind of agents in this environment. These agents will help in some of these activities, helping the human supervisor or helping improve the performance of the system of all. Our objective are create a multi-agent architecture that allow embody intelligent control strategy and field devices, introduce an improvement in decision support at plan for occurrence and allow an user support, through machine learning algorithms, specifically neural network algorithms, anticipate situations like a prediction that may occur to improve the system performance, and reduce the supervisor intervention in selecting and implementing appropriate structure of function blocks. To understand our architecture, it's necessary to understand the function blocks. Smart configurations are implemented by intelligent algorithms that are incorporated to the sensor using standard function blocks. These blocks have basic functions. When combined, are able to implement some control strategies. In our case, a neural network required for our algorithms. Foundation field bus is able to distribute the control of the process in the field. The sensors and the actuators have embedded process that can execute the algorithms in the distributed way through the function block. This processor can do small processing, but it's sufficient to implement some neural network, simple neural network. Okay? In our laboratories, we developed many works using neural network with modeled by standard function block. Here we can see a mathematical model of function block of neural network implemented in standard function blocks. characterized and arithmetic function blocks to implement this simple neural network. This has some, using neural network, we developed some kind of applications like self-calibration, self-compensation, self-validation using standard function block, algorithms applied to the sensor noise extraction problem, and fault detection and isolation system. Some of them use a natural network implemented in function blocks. Understanding the function blocks and the natural network made by function blocks, we will present our architecture. This architecture is composed of a multi-agent system that generates inspect routines of the collected data in the plant sensor. Each agent or group of agents in this architecture is responsible to executing activities such as monitoring, surveillance, and communication. The aim is to induce the agents to evaluate field interface data, investigation inconsistencies that may impede the productive process, such lack of precision, external noise, alarm interpretation, and others. Here we can see the anatomy of our agents. It's composed of two parts. The first part is the learning part. It's necessary to the neural network pass by a training phase. This training phase we call learning, because the neural network will adapt, will learn, will train the situation that will be found in the field devices. This learning phase here is making supervisor level and communicate to the gateway using the JADE FIPA field bus layer. JADE is a framework for developing agents in Java. Okay, it's FIPA compliant. FIPA is foundation, interactive physical agents. Okay, so we have made this learning phase in our structure, and the bottom of this anatomy we have the action phase. It is a neural network, a trained neural network implemented using standard function blocks and using the parameters learned in the upper part. The agent's allocation and deallocation field devices is made by chain function blocks interconnection. We allocated the function blocks and we interconnected these function blocks performing a neural network. So, in some moments, these agents is made by making a monitoring, and some moments these agents are acting, for example, extracting noise. So, these architecture function blocks have to change depending of this action. So we face a problem. In the field bus network, we can change the field box configuration on the file. We need to stop the plant function and restructure the function blocks, and after restart the plant. We developed some kinds of this to bypass this problem. We just create a bigger, great neural network, and from then we just change the values between the two function blocks.